How's it going, everyone? Welcome. Eber Gonzalez here, and today let's going to now do this particular exercise about coercion as a way to recap what we have learned so far, and then we move on to now what is equality and the static typings. I'm gonna make a quick pause here with the static typings because the idea is on JavaScript as a way to do a quick recap of how do I get here is to say, hey, first thing first, I'm doing this is because I want to know how this particular tool does. Pretty much like you have now a range when you want to fix your motorcycle, or you want to now have a particular diet to follow to get the outcomes that you want when you hit the gyms and also sleep and all that kind of stuff. This is the same here for a JavaScript. And unfortunately, like it or not, most of us are now known as professional guessers. And I am not, I am definitely not in favor of that. I was one of them. I'm still sometimes, unfortunately, because you never know something truly know, but I will know that at least I know the fundamentals. All right, and this is part of the reason why we're doing is this series of videos, this particular course. Right now, looking at the philosophy of coercion, and then actually now do an exercise to get ourselves familiar with, and because there is no other profession that you are known as a professional guesser, and you're getting paid for, you know, holy moly. But in any case, so this is the reason why I'm actually doing this, and I want to organize this pretty much like a hash table. So I want to have now a hash table in my mind, so anytime that I need to access to this data, it's like I get that pretty straightforward, right? It's also helping for me. It is also helpful for me to do that, since it allow, well, as I told you, and when it comes to now solve specific problems or find ways to create something, so I know what is the fundamentals, and then I can play with it like an artist or athletes. So this course is made by Kyle Simpson. Shout out to Kyle Simpson, Jesus. And I'm just taking notes out of this as a way to make sense of this particularly pillars. So once we already understand now the basic stuff on the language, which is what is a statement, what is an expression, what are now the values, what a possible values that can we have, and also is the control flow statements like if, like for, and some looping control statement like for, while, do while. So once we already know the basic stuff here of how can we write particularly set of instructions, okay, when it comes to now is dive deep into the fundamentals, the pillars of JavaScript, especially when you want to build now not only small statements, right, 310 200 line of code. We're talking about now is big applications when you want to build now uh, Facebook or Twitter or that kind of stuff, right? So, and also because if you're gonna offer your service to a particular company, they need you to do that, right? They need you to be the right gal or guy. So because of that, so the three pillar here that Kyle Simpson mentioned is now first is the type system, which is the primitive, the object, understand the difference between them, as well as the corner cases when you're using primitive, and how you can get the value of this or the type of this, right? Why we get an object when we call a null, and how now when you unset or set something, why we prefer to go with null rather than using empty string. And I think this is something that opened my minds, because I am too often quite familiar to use empty string to define now string values, where I prefer to go with null values rather than undefined. I prefer to go with null. And we're gonna see that why, right? So so we can use now null and undefined. Also is this type of value that we're gonna get in this set of values we can get with type of, as the when you wrote the operator type of, how we can get ourselves familiar with the spec by looking at the docs, all right? And also is another corner cases like 0.2, 0.1, 0.2, and why this actually generate like 0.3, 0.4, okay? And it's because it's the limitation that we have in our computer memories that we need to represent this somehow, and because 1 divided by 3 is not is not an accurate, so you can describe accurately with the decimal or the binary system that number, all right? And by accurate means, like, for example, when you divide 1 by 4, okay, it gives you now 0.25, right? So you get now this finite representation of this. So because of that, well, computers, when they compile or interpret your code, they now round that number for you. So you can solve this by actually applying some to fix methods to actually get you only the 2-point decimal. Other important stuff relevant to the language especially is like the type of emptiness. You have now undefined, uninitialized, and Jesus, I don't know why that is so hard to me. I didn't anyway. So undefined, Jesus. So undefined is when it's, so undefined means when it's not created. Okay, you didn't even create that. This is undefined. I mean, you create, but it doesn't have any value assigned. This is undefined. Undeclared is when you didn't even create that or declare here. And the uninitialized. So this is true for example, blocks go variables like let, right? Something that we're gonna see that later on. But this tells you that variables that you define are not initialized with undefined. Okay, so this is particularly nuanced here with type of emptiness, as well as the different or special cases that we can have in primitive. So for example, what is a nan, what is a positive and negative number, why nan is the only type of value that is not equal to its identity, all right? And where nan came from the IEEE 7054 spec that describe now is the representation of numbers. So the number type actually have a limit of 2 power 53. So you can represent now here is a 9 followed by 15 digits, all right? And this is known as quadrillion. So anything that is bigger than that, we use now big N for that. Useful for astronomical distance or finance or cryptography. This is the most common use case. and also for positive and negative value when you want to define its directions. All right. So also understand now the abstract operations, all right, or the coercion, and I prefer to call that abstract operations, but we know that as coercion, okay, which is the way of how now the JavaScript transform this particular or identify is the type of this value. Now, this is something that you can have access to, and this is when the hard part kicks in, because if you cannot if you can have access to that, it is very rare that you know that. Also, this is why now JavaScript, the entry barrier of JavaScript is so low, because you don't need to care about to handling all of these different types, like for example in Java. Okay, so here you can now rely on these abstract operations, conceptual operations that happen at ECMAScript language level, right? That any time that you now try to use a particular value, it tries to convert that into something that makes sense. So because there are several of those abstract operations, all right, we're gonna focus on the most common one, which is the toBoolean, the toString, and the toNumber, as well as the toPrimitive. So with toPrimitive, you say, hey, anytime that I receive, I want to coerce that into a primitive. So if you give me now a primitive, it makes sense. I'm gonna coerce that into primitive. If you give me now, for example, an object here, I will go first to the string operation. So because this toPrimitive, internally the JavaScript is going to pass now a hint, whether this is a number or a string. Okay, if this is a number, it's going to run is the value of that primitive. If it's not, it's going to run is not just the toString, and vice versa in the JavaScript language or in the string primitive. Okay, so the idea of this toPrimitive is that if you pass something that is not a primitive, let me go to that, which is this. If you pass something that is not a primitive, unfortunately I didn't take note of that, you know, but I have this, the toPrimitive. Okay. I think I already make the primitive hints. And this is the toPrimitive, and the hint 7.1.1, right? This is more like the 2026, this one, which is gray. Okay, there you got it. Okay, so so here is what it does. It say, hey, assert if the input is an ECMAScript value, whether it is a string, so whether it's a primitive or an object. If the type input is an object, then you're gonna do this. If the preferred type is not present, let the hint be the default. Else, if the preferred type is a string, let the hint be a string. If the preferred type is number, let the hint be number. And then let the exotic toPrim be the methods and the toPrimitive. And if the exotic toPrim is not undefined, then be the result of calling that. And if the type of the result is not an object, return the result, all right? However, so as you can see here, it's going to do this. It's going to check if this is a string first, all right? If the preferred type is not present, let the hint be default, all right? The type here, be the default. Exactly, the preferred hint is not present, let the hint be default. If hint is default, send hint to number and return ordinary to primitive here. So the point of this is that it's going to initially prefer to evaluate this as a string by running that primitive, the toString or the valueOf, all right? So this is why, for example, anytime that you want to now coerce this, it's going to first look at the object string, for example here, ordinary to primitive, return ordinary to primitive, assert the type hint. If the string, it is value either string or number. If the hint is a string, then you're gonna run this method, toString and valueOf. If it's not, the valueOf a toString. And for each name in method name in list order, do this. Check if this is callable, right? And if result is not typed here. So as you can see, this is something that is recursive for objects until it finds is that. So the TLDR of this, which is something that it's not quite clear to me, and this is good because it is an invitation to understand that. All right.
This. And fair warning.
With the abstract operation here?
So earlier we described, and I mentioned a thing called a conversion, disconcern. And we need to make it, if we don't have a primitive, we need to turn it into a primitive. So if we have something non-primitive, like one of the object types, like an object, an array, a function, whatever, and we need to make it into a primitive, this is the abstract operation that's going to be involved in doing that. By the way, the abstract operations are not a thing the JavaScript engine, they're not like a function that could somehow be called. They're may in fact be actual methods inside of a JavaScript engine or not. They're not like required to be actual things. But when we call them abstract, we mean they're a conceptual operation. So anytime you have something that is not a primitive and it needs to become a primitive, conceptually what we need to do is this set of algorithmic steps, and that's called toPrimitive, as if it were a function that could be invoked, okay? So the toPrimitive abstract operation takes an optional type hint. So in other words, it says, if you have something that is not a primitive, tell me what you think you would like, what kind of type you would like it to be. If you're doing a numeric operation and it invokes toPrimitive, guess what hint it's going to send in? It's going to say, I would like to have a number. That doesn't guarantee you a number, by the way. It's just a hint to say, the place that I'm using it, I would like it to be a number. If you're doing something string-based, guess what hint it's going to send in? It's going to send in string. Those are basically the only two hints. It can say, I would like it to be a number, I would like it to be a string, or I'm not going to tell you at all, so just give me whatever primitive you can, okay? Another thing you need to understand about the algorithms within JavaScript is that they are inherently recursive, which means that they define something, for example, to toPrimitive. If the return result from toPrimitive is not a primitive, if it's another non-primitive, like another object, then it's going to get invoked again, and it's going to keep getting invoked until we can get something that's an actual primitive, or in some cases get an error, okay? So there's a lot of these sort of spec machinations that happen that are recursive. And when we look at coercive equality a bit later, you'll see this idea that it's sort of being reapplied over and over and over again until we get a full result. So toPrimitive, the way it works, essentially boiling down the algorithm, the way it works is that there are two methods that could be available on any non-primitive, any object, function, array, whatever. Any non-primitive, there are these two functions. And you've almost certainly seen these before, the valueOf function and the toString function. And this algorithm says, if you've told me that the hint is number, then I'm going to first try to invoke the valueOf, if it's there, and see what it gives me. And if it gives me a primitive, then we're done. If it doesn't give me a primitive, or it doesn't exist, then we try the toString. And we either get a primitive or not. And if we try both of those, and we don't get a primitive, generally that's going to end up resulting in an error. Okay? That's if the hint was number. If the hint was string, they just reverse the order that they consult them in, but they still essentially consult both of them. So if the hint is string, we would ask for that object, that non-primitive's toString method, and if it has it, use what it returns, and if it gives us legitimately a primitive, like a string, which it should, then we'll just use that, and then we'll try valueOf, okay? So just keep in mind, if you're going to use something that is not a primitive in some place that definitely needs primitives, like math or concatenation, in your mind, you should realize it is going to end up coercing it through this toPrimitive algorithm, and it's going to end up either invoking the value of or the toString. We'll see examples of the usage of those in a little bit. So let's talk then about the next abstract operation. It's called toString. The toString abstract operation does what it sounds like. It's very descriptive of it on the label. It takes any value and gives us the representation of that value in string form. And almost every value that you can imagine has at least some kind of representation in string form. By the way, in the parentheses, I'm noting the actual spec sections as they exist currently in the version at this moment, which is ES 2018. They voted on the ES 2019 spec, and it'll come out a little bit later this year. Hopefully, most of the section
numbers. So you can have access to the toPrimitive through the
okay,
symbol.
So the toString operation. Boiling down a bunch of details, let me just show you some examples of things and what they end up producing as a string representation. And for the most part, these are exactly what you'd expect. If you had a null value and you ended up doing that toString abstract operation in some way, you'd get quote null. Same thing with undefined, true, false, floating point numbers, even the 0. Things get a little strange when we look at the -0. Remember that. We already saw that it lies. The toString operation for -0 lies and produces a quote 0. So that's one of the corner cases, and we'll talk more about corner cases in a bit. All right, so if we call toString on an object, remember, it's going to invoke the toPrimitive with the string hint. So what's that going to give us? Remember, that's going to end up calling toString first, and if it's present, and then it's going to use valueOf. That's the order that it does. So what's that going to look like on some particular object? Well, if it's an array, for example, arrays have a default toString, which serializes a representation of the array. It's a bit of a strange serialization, in my opinion, because they're leaving off the brackets. So if you serialize a empty array, you get an empty string.
This is a good example. Anytime you want to now is try to coerce these values.
How am I supposed to know whether it was?
Okay.
You know,
so JavaScript is going to say, hey,
but
this one.
Nevertheless, this is how it works. The built-in toString on arrays leaves off the brackets.
Number context.
If we have an array with some contents in it, it'll show those contents unless they're null and undefined. And this is even weirder, the toString definition for this. I actually was just reading the spec the other day, and I was like, why?
Addition with string.
Nulls and undefines, when they show up in arrays, just get left out. I mean, they're there presently. You can see there's a comma there. They're there presently in terms of position, but they're not represented as nulls and strings the way null, as nulls and undefined the way null and undefined when toString do. A bizarre, in my opinion,
symbol to primitive methods, hint-based behavior.
Essentially, array toStringification is like, maybe you could use it in the dev console, but I would never use something like this in my program because of all these weird corner cases of its behavior.
So it's in symbol here, toPrimitive. So this toPrimitive is a static data property that represents the well-known symbol toPrimitive. All type coercion algorithm. And if you remember the type coercion algorithm, that can be is these abstract operations, this toString, toBoolean, toNumber, among other ones, like here, let me see, no. On the abstract operations, or abstract operations, here, why you don't open this? Abstract operations, yeah, but like, but you don't open that? Really? You don't open that? Really? You don't open that? Wow. Anyway. Okay, well, all of this, right? The abstract operations, okay, the type conversions is to primitive, to Boolean, to number, to integer, to int32, to unity, you know, all of this abstract operations. Number to string is another one, right? which and also to object operations, you know, is the actual operation to object to convert arguments to a value of type objects as it is, to property key. So all of these abstract operations are here. All type coercion algorithms look up these symbols on objects for the methods that access a preferred type and return a primitive representation of the object before falling back to users of the object valueOf and string of methods. What does it mean? That when you're trying to now coerce this value, right? And if exactly when you are trying to coerce this value, it is invoking now that particular result, even though you can have access to this. Is interesting. This is very, very interesting, especially on the toPrimitive. Holy moly! Oh my god! So anytime that the language is trying to coerce something here, it's going to call is the toPrimitive, which is they're using a symbol as uniquely identify to use that as a uniquely identifier. But this symbol here returns primitive values of the type symbol, okay? And the description of this is creating symbols. So create a new primitive symbol with optional here, new symbol. This prevents authors from creating an explicit symbols wrapper object instead of a new symbol like this. But they don't tell you why or when can we use this. All right, when can we use symbols? So what is the main use case for symbols? Okay. Creating unique non-enumerable property keys that avoid naming conflict. Here's a primary use case: avoiding property name collision with the symbols or meta programming and protocol definition. This is interesting. So symbols are using for meta programming and protocol definition. Okay, meta programming is objects that are describing the behavior here. In other words, when you talk about this iterator, this is what you want to do. Creating hidden properties here. Symbol private. Library framework internals API. React use symbols internally. React element type symbol.for React element. Express.js style middleware. You say, hey, this is now a middleware. And apply the middleware symbol. Well-known symbol for language features. toPrimitive makes objects iterable or indicate what is the expected behavior. So define the behavior of iterables on that object. Async iteration has instance of behavior. So they allow you to now have access to the language features. One of them is the iterator and toPrimitive. toPrimitive is for coercion, okay? Or you can use this for defining meta programming and protocol definition. That's okay. This might go beyond the scope of this video, okay? But I will definitely use this example here. I will definitely use this particular example. So by defining the object where internally it has now this hidden properties, you may call, or or can have access to these behaviors or this algorithm, here you're saying is anytime you receive a hint, which is anytime you try to cohere this primitive, if this is a number, I want you to return this. If this is a string, I want you to return the formatted string. This is part of the meta programming here. Or if this is default, for default context, return the numeric value here. So, well, if you do this, if you do the string context, it's gonna give you now, anytime that you want to coerce that value, okay, it's gonna call now the string, for example, string conversion here, or the current temperature of that. If you want to now call this as a number, you say like number, all right? It's gonna give you now is the 25 and 35. This is something useful to modify this behavior or to have access to this behavior when you want to show them in a particular format. How often do you use that in programming? Honestly, I never have to use this. But why this is important to know? Because you can now that you can have access to these abstract operations, like toPrimitive over with a symbol, okay? And any time that now JavaScript is trying to coerce or converse this value, which is in our case is the Celsius, and I really love that example. Anytime that we're trying to coerce that value, all right? So for example, with primitive, no, this to primitive here. So anytime that it's trying to coerce that value, let me put it here. In fact, let me do this here. You know, an example here. An example, you know, example here. This is an example. You can now have access to these abstract operations, and any time that there is a coercion of this particular value inside of an object, in our case, it's a, hey, if we are trying to do now a string coercion, I want you to now return this format, right? Or anytime that you do now a numeric operations, I want you to return that as a particular value, you know, as a normal value, and so on and so forth. So again, the idea of this is to see how you can now is have access to these abstract operations. When this might be useful is just for educational purpose, I must say, okay? But it's to at least understand that what's going on when you are trying to coerce now some value into a primitive, okay? Okay? So, and it's gonna do this in a recursive way, okay? Until it finds that it cannot do that and throw an error. So for example, trying to coerce now an object to a primitive is something that is not going to happen, right? Because objects are not primitive. So in any case, we can also try to check that, as it is. So this is what it's going to do. We also describe about the toString and what's going to do when you receive now primitive values. Well, this is quite intuitive. If you receive now which is the stringification of primitive. It's pretty straightforward. There is nothing wrong with that, except for negative values that is transformed into 0. And the other is the stringification of objects, which is when you pass now an array, you have now this empty string. If you pass now an array with null and undefined, you have now this comma. If you pass now an array with 1, 2, 3, it gives you now the 1, 2, 3 value without the without the holy moly, how do you call it? Without the with the brackets, okay, square brackets. And what's next? And also now the numberification, which is a more interesting topic here, which says anytime that you receive now a string and you want to convert into a number, is going to do most of the time, all right, if you pass now, unless you pass now an empty string, you're going to convert that into 0. For any other value, it's going to try to convert that into a proper value, except if this is not a valid number, which is now a NaN. Okay, and also for the booleans, so far so good, which is undefined to 0, null to 0, undefined to NaN, and null to 0. All right. All right. Okay. And the other is the numberifications of objects. So here, if you pass now an array and you try to convert that into a number, if this is an empty array, it's gonna give you now a 0. All right. If this is an empty array with an empty string, it gives you now also 0. If you pass now only one single value, it's gonna give you now that particular value. If you pass now a negative, if you pass now null or undefined, it's gonna give you NaN. Where now when you try to coerce that into Boolean values, undefined give you NaN and null give you 0. So you started to see how the thing is gonna work. And for an object, give you now a NaN. You can also override that behavior with the value of, right? A primitive that you can have access, or the method that you can have access. And then we have now the toBoolean, all right? So with toBoolean is just like, unlike the toNumber or the toString, which is now a more algorithmic way of doing this conversion. In a Boolean, it's just a lookup table, pretty straightforward. If this is positive, negative, undefined, null, empty string, NAND, or false, all of this becomes to false C values. Anything else is a true T value. Empty string, remember, empty string is false. So for example, a white space is true. Functions and true and all that kind of stuff are true. The TLDR of all of this is that with the coercion, now we are looking is at these particularly corner cases, and that coercion, when you do now is with, when you want to coerce multiple values or evaluating now an expression of multiple values, for example, addition, is going to prefer now the stringification of that, which is, that's what they prefer, all right? The other is now with strings to number, or the Booleans, right? Anytime you want to coerce that into something into Boolean, all right, it is preferred to be much more descriptive about this. Okay, so for example, wrap them with a Boolean value, even though there's some corner cases with Boolean, all right, if you pass now some special characters, it becomes now true, all right, if you pass now an empty value, it becomes now false, all right. So why is this important of looking at these coercion techniques and so on and so forth? because sometimes this is what you might and want to expect from the language. So for example, boxing is this particular operation that anytime that you want to have access to a data in an object, it wraps this value temporarily so you can have access to the method. All right. So at runtime, so for example, when you're doing now this kind of stuff, so at runtime, it's going to JavaScript now wrap this object or wrap this value with the proper object type. In this case, if well, a let's say this is string, right? And the next and allows you to have access to this method, which is makes this very convenient for us to go with. And some of the corner cases that we're going to encounter as we do this type coercion. A lot of them are from numbers, all right? Some of them are with booleans, and with number is to say, hey, if you now pass now an empty string to a number, it's going to coerce to 0. Even though you pass now, for example, special characters, you're going to coerce that to 0. If you pass null, it's going to coerce to 0. If you pass undefined and you want to non-verification of this, it's going to give you now nan. If you pass now an empty array to a number, to coerce that, it gives you now 0. It gives you now nan. It gives you now 0 and 0. If you pass an object, it gives you now an n. And similar for a string. If you pass now a negative 0, it's going to give you 0, not the negative. All right. If you want to stringify the null, it's going to do the null with undefined. But if that is inside of an array, right, it's going to give you now an empty string. And the another corner case is the empty string, because empty string, when you are now evaluating that, is going to give you now a 0. Okay, perhaps that's also something that you want. And another is with the comparison. So anytime that now JavaScript try to compare two values, it's going to run this coerce operation on those values, and therefore return now a boolean. So in this case, this is a famous example of say 1 greater than 2 is greater than 3. In our case, this is true. You say, yeah, but when you do now this, you say, okay, this is true, this is true. But what happens when you want to now evaluating is this multiple like this? So here is doing is now this Boolean coercion, because when you're evaluating now comparison, okay, is doing that. And when we talk about now the coercion and all of this kind of stuff, again, this is something that I will briefly summarize this philosophy of coercion in couple topics, or in 3 topics. First is the culture of learning, that you need to be intentional about what you're going to learn, how you're going to learn, and therefore you want is to write the code so you're describing the intents to others, and also to let junior developers to learn more about this. And even that is, it puts now the burden on you. All right. So if you're going to be a professional in this field, all right, and a profession, the etymology of this comes from the old French word profession. I think I did it right, profession. It means that secrets vows upon entering into a religion. In our case, secret vows upon entering into this devotion, into this dedication, into this field industry. Okay? So I think this talk a lot of the honesty that we need to have as human and act accordingly on that. The other aspect is more like the what. First is about the culture of learning. Yeah, first is about the culture of learning. Okay, and how you need to be intentional with the coercion. The other topic is what the code represents, and it is a form of communication. So this code that you are write or gonna read at some point must describe what it does or how it does. Okay, this is when you have now the imperative or declarative programming, and the comment must say why you're doing this. And I think this particularly point of view are relevant, especially when you are going to write code or when you're going to develop features and so on and so forth, or you're going to read that code. Is that you need to make the intention of the code be explicit, all right? Or you need to make the intention of your code be easy to understand, and that communicate that what needs to be done, how it does or what it does, as well as why you're doing this. Okay, makes sense. And last but not least is that there are implicit stuff, or in terms of coercion, the implicitness of this is something that is going to help us sometimes. And if you don't know something, it's important to understand the features. So I will summarize these three topics of this philosophy of coercion, all right, and say it's important that if you're going to use coercion, you be intentional about it, you be descriptive about this, all right, and and promotes the learning culture around this for yourself and for the others. That anytime that you are writing your code, you're writing this coercion, you need to describe, besides what it does and how it does, also why it does through comments. Okay? And sometimes in some implicit stuff that you're going to rely, or that you don't know how that works, it is your job and your job alone to understand that, right? So the three pillars here of this philosophy of coercion is, first, be intentional about what you're gonna do, promote a culture of learning while you are communicating what needs to be done, how it does or what it does, okay, which is your code, and why your code does that through comments. And if you are going to use some implicits or in your code, if you're going to describe or if you're going to use some implicit stuff about that, learn it and be so learn it and also try to describe them. All right. So understanding your features. Why are we and why am I mentioning this? Because especially most of the time people are going to write a lot of this kind of code, all right? And now that the peace time has come to an end, I will say that because a war now is a war begun, at least in Iran and Israel. Then they're gonna demand a lot of people that actually know what they need to do, or that are good at what they're doing, okay? And this is not going to be as easy, bro. This is not going to be as this is something that it's going to require is some professionals, athletes, people like that. All right. So people that know what needs to be done when you need to write this particular code and why this code doesn't work and so on and so forth. So we are just only um, describing is what are the stuff that, for example, Kyle Simpson and among other developers are looking when they are now writing the code, at least in JavaScript, and especially with understanding features of the language like the coercion, all right? That not only that you need to learn these additional features, and that you have to be intentional about that because you're going to describe that among others. And when you're gonna write your when you're going to write your code, you need to describe is what it does, how it does, all right, as well as why this code does this. And anytime you use now implicit stuff, describe this. And if there's something, and there's some implicit stuff that you know that you don't know, it is your job to understand that. And to me, it's quite. This is Jesus, Jesus, Jesus. Oh my God, why am I why am I saying this? Because if you are a military or if you are in some conflict areas where there is no room for errors because it's gonna cost your life, you well very know what you're gonna do. Oh, yes, absolutely. So the same here now with the equality. So with the equality that we have now is a double and triple equality, right? And even though that Kyle Simpson described this and say, hey, if you're trying to understand your code, it is crucial to understand how JavaScript works. Perhaps this might be quite obvious, but there is a reason why things are obvious, because they are not so obvious. So the idea here is to understand now what's happening is with the equality. All right. So I think we did the implicit coercion here. Oh, okay. Let's go to this. So this is the equality here. So we look at the double and triple equality. We explore now the algorithm here. Again, this is still being the type system of the type conversion. Okay, what it is using the abstract operations, and now is the equality operation, which in other words, this is called as, let me call this abstract operation. Come on, man. I don't know why. I don't know why. Anyway. Oh, I get it why. Nope. Abstract operation. No, nothing. Okay. What about now? Exactly. So no abstract operations like this. You got the type conversions, all right? All of this we have mentioned are about type conversion. This abstract operation is just about is type conversions. And the other abstract operation is now comparison and testing. Okay? Comparison and testing. And I prefer to use this, it use not equality, but I say is that it's comparison. Okay? Comparison abstract operations, man. Type conversion, and the other is comparison operators, as well as the operations on objects. Operations on objects here. Operations on objects here. The abstract operation called operations on objects. And the group by. Here now the group by is describing here the algorithm here. Interesting. And what this is does, if it's callable, is false, throw a type error. Let the group be the new empty list. Items record get iterated, let k be 0, and repeat if this is greater than -1, then throw a completion, a newly created type error objects. Interesting. So if you have more than what you can represent it, at least in the ECMAScript, how do you call it? At least in the IEEE 754 spec, all right, that allows you to represent is up to this length, all right, 253 minus 1. If you have more elements than that, then I'm not gonna do this. Okay. And this is how it's going to iterate through all of this. Iterator step through all of this. If coercion is property, interesting. And operations on iterators. The iterator record. Okay. Let's get into this, my friend. Get iterator from methods. Okay. Get iterator flattenable. Iterator close, iterator valid, iterator complete. Iterator step. Interesting. And syntax directed operations. Runtime semantics evaluation, scope analysis, static semantics bound names, and all that kind of stuff. Okay, it makes a lot of sense. Okay. So far we look at the type conversions. With the first abstract operations, was more about the type conversions, and the most common ones: to boolean to string to primitive, to boolean to string to number. All right. And some particularly exercise to see how you can do this coercion on that in some corner cases. Okay. And then now the comparison abstract operations. Okay. Okay. Holy moly, bro. Okay. Testing and comparison operators. Require objects. And here is when we explore is now the same type and same value, as well as the loosely equal and strictly equal. Okay. All right. Okay. Good. Okay. Holy moly, bro. Okay. And the coercion, which is type operations. Exactly. So abstract operations types. Type conversion. Exactly. Coercion, abstract operation, type conversion. And the other is the equality concept, which is abstract operations comparison, testing and comparison operations. Is array, is callable, is constructor, is extensible, is regular expression, is a string well-formed Unicode, is send type. Okay, interesting. Okay, testing and comparison object. Abstract operation. Testing and comparison objects. And comparison objects. Makes a lot of sense. Okay, and here because there are several testing and comparison operators here. We're just going to focus our attention is on the most we got on the most debatable or on the most hot or the most controversial topic, which is what happened when you want to compare two types. Makes a lot of sense. Makes a lot of sense. Okay. Holy moly. So if you look at this as an array, it's if the argument is not an object, return false. If the argument is an array exotic object, return true. If the argument is a proxy exotic object, then perform the validator non-revoked proxy. In all of this argument, in all of this is interesting. All of this is a bunch of if statement. All of these algorithms are just like that. It's just a bunch of if statement. If it's this, if it's not, if it's that, blah, 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 yada, 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 yada. Holy moly, bro. So, so, so now my mind has been opened up. So my mind has been opened up about why we're looking at this, especially when we're looking at this triple equality, okay? And I know that Kyle Simpson is trying to make this much more accessible, okay, for the masses. But it is up to you to, if you really want to understand, to dedicate your attention to know more about this, to dive deep into this topic, to get the truth out of this. And that's interesting because I am not a particular. I am not a mathematician or a scientist. I just have the drive, the devotion to understand now this. All right? Because it's something that I need to know. If you're going to use this particular tool, is require you to do this. And not only that, to know, but also to build, which is where it now comes this. All right. Okay. Good. So what we're looking here, okay, is now the double and triple equals, the algorithm that is running this, okay, and what it's doing this, for example, is loosely equal, is less than, same value, non-number, same value, 0, testing and comparison operators. So for example, like the same type, okay, hey, are they the same type or not? And here is when you're going to look at this. Is it strictly equal, and is the double equal? If this is strictly equal, it's going to call this. If they are the same type, is false, return false. If x is a number, then return the number equal to x and g, which is another, the number equal here. The abstract operations, number equal, takes an argument x and g and return a boolean, and it perform the following step. If x is 9, return false. If g is 9, return false. Okay, same value, 0, equal. If both of things are equal, okay, is x and g, is if x is g, return true. If x is, okay, if f is g, okay, if their numbers are equal, exactly, if x is g, return true. Exactly, if they are equal. Number equal, another abstract operation here. Okay. Is there equal here, or same value, or bitwise operator? Okay. So definitely the things that are for the masses are not for the individual, man. So okay, now is it strictly equal? Here you have the same type, is false, return false. If x is number here, then return the number equal, okay, to actually verify if they are both are numbers, how this numeric operation happens, and then return the same value, non-number. Okay, if they are the same type, okay, if they are the same type, is x is false, return false. And they're verifying is now if they are the same type. And the abstract operations in types takes the x and g, which are values, and returns a boolean. It determines whether or not two arguments are the same type, and it performs the following step when called. So if this is undefined, if both of them are undefined, true. If both of them are null, or boolean, or number, or big int, or symbols, or string, or an object, return true. Otherwise, return false. Holy moly. If X is an object and G is an object, return true here. The property of an object are uniquely identified using property keys here. A property key is either a string or a symbol, and all strings and symbols, including the empty strings, are valid as property key. A property name is property key in a string. But again, okay. And now the properties of this object, which is a value, the get, set, and enumerable, and configurable. Data property, accessor property. So it is the same type here, the same type and the same value. Okay. So if the same type is X and is false, return false. If X is a number, is this. So look at this. It's loosely equal. It say, hey, if the same type is true, this is also something that, for example, concatenation operators or addition operators, say this one. The unity operator here, like this, is it toNumber or how do you call this? Because I want to close the gap a little bit here. With addition. The addition operators here. And this is language expressions. So when we talk about expression, it's because they generate now a value, bro. ECMAScript language expressions. You have the identifier and the binder here, but not reserved word. Exactly, the identifier and the identify star char, the Unicode D star, any Unicode point with Unicode property ID star. Okay. Binding identifiers. Okay. The addition operator either performs string concatenations or numeric additions. But again, this is language expression. So what's the difference between language expression and statement? Evaluates a value, and statement perform an actions or operations. So all of these are expressions here. And now it performs an action. Or an operation. It performs an action. And it performs an actions. Perform action and they'll produce values. Exactly. Hybrid cases. Some constructor can be both depending on the context here. Alright, okay. Except this is in Python. In Ruby, almost everything is an expression. that returns a value. Okay, it produces a value. Because they are construct here. Okay. So this is the language expressions, the additive operation, the addition operators. So we went through this, all right, to the double equal and the coercive and all that kind of stuff, and to understand that the summary of the double equal and the triple equal, if they are the same, perform the triple equal. All right, check if they are the same type. So, however, if you look at this, it's nothing about nan. It's not telling you about nan. So nan is the only value that is not the same type or equal to its identity. Somehow it produces a different value. Okay? You have to be careful when you want to compare is two nans. If you want to truly know, or if you want to truly compare two nan, you say, hey, if they are different, for example, like this, if they are different, then, all right, now I know for sure that these two not a numbers are the same, or it's not a number. You know, if you want to make now not a number comparison, okay, it's because they are not the same to itself according to the language. Okay. But positive 0 but negative 0 and negative 0, they are the same. And this double equals here, what it's doing is to say, hey, because this is what we walk through this, if they are the same type, yeah, that's right. No, it's this. So if they are the same type, it is true. Then return is strictly equal. So evaluate that. If x is null and g is undefined, return true. Regardless of its position. However, if the number, if one of them is a number, exactly. However, if one of them is a number, I will prefer to do a numeric coercion. Okay? I'll prefer to do a numeric coercion. So if this is a non-primitive, exactly, I'll prefer to do a numeric coercion. If one of them is a number and a string, I will prefer to do a numeric coercion. If one of them is a big int and the other is a string, I will return now is this one. So big int and g is a string. So let the string to big int. If n is string to big int, it's going to now stringify that. So in other words, if you say, for example, 2n is equal to 2, or the string 2, all right, it's going to stringify that. It's going to stringify this big int, right? So it's gonna say, hey, if one of them is if a big int, all right. So if the first is a big int and the other is a string, I'm going to now convert the big int into a string. If the reverse is this in the other one, I'm going to call now is loosely equal. So if the string is g and the big int, so for example, it's going to do this, and it say, okay, if one of them is, this is interesting. So if one of them is a string and the another is a big int, I will try to coerce that big int into a string, and therefore do that. If one of them is a number and the another is a string, I want to do a numeric coercion. I want to do that a numeric coercion. So for example, like this. I'm going to do that a numeric coercion. Okay. If the other is Boolean, okay, if one of them arguments are Boolean, I'm going to do now a numeric coercion. Okay. Interesting. If x is a string and a number is a big int or a symbol or g is an object, return is loosely equal, and then going to try to cohere that into a primitive here. toPrimitive here. So I want to try to coerce that into a primitive here. Okay. But I'm going to coerce that into primitive based on what? You know? If x is either a string, a number, a big int, and g is an object, return is loosely equal, and I'm going to coerce that to primitive. So if loosely equal now, receive this into a string exactly, into toPrimitive. toPrimitive say, hey, I want to find ways to coerce this, and first is I'm gonna do a string operation and then a numeric operation. So therefore this is going to be converted into an object, and if the other is a string, I'm going to coerce that into a object. All right, so this of course will be false, because what it's doing is to coerce that into object. That's what it's doing here. Holy moly. Oh shit. God damn it. Fuck that. Okay, exactly. I'm trying to now coerce that object into a primitive, and the first thing I'm gonna do is to check that it's in a string. If it's not, into a number. And in our case, what is the stringification of objects is, in this case, is objects are like that, but the stringifications of arrays is an empty string. Mm-hmm. 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 Okay. That makes a lot of sense. That makes a lot of sense. So if the types are the same, so do a triple equal, right? However, if not, let me check if they are now, if one of them, if one of them are null or undefined, okay, so they are equal, right? If one of those parameters I'm going to compare, then is one they are equal. However, if one of them is a string and the other is a number, or vice versa, I'm going to do now a numeric coercion. If one of them is a big int and a string, I'm going to do a stringification, right? Uh, a string coercion. If one of them is now an object or a non-primitive, I'm going to call now a toPrimitive into that, right? Right? And therefore, and the rest is going to prefer is the toNumber. Holy moly, bro! So now we now reveal the veil that we have in our the veil, right? We reveal is uh, yeah, we open up our eyes to what it is, this stuff, this magic stuff, and then how you can rely on this. All right. So anytime that you want is to use is the double equal. For those who really know, is because well, you know what this things is doing. Um, yeah, you know what the things is doing, which is great. And then you are telling to the you're describing here that you are sure what the type of this is. If you're doing a triple equal, you might not know what the type it is, so you are now defending yourself against this. Mm. Holy moly. Holy moly. So when you do this kind of stuff, okay, first, when you do this kind of stuff, okay, so what is the output of this? Well, uh, if both of, so first is going to evaluate this expression, which is going to coerce that into a boolean, and the boolean value of an empty array is true, right? But if you want to negate that, well, it transforms that into false. So now this becomes false. And when you are doing this type, and when you're doing this comparison coercion, or this, yeah, comparison coercion. If this is a boolean, right, and the other, if this is a primitive and the other is an object, it's going to coerce that into a primitive, and the primitification of this, it has several steps. But first it's going to check, now let me see if I can do the string conversion, and the string coercion of this is now an empty string. So this becomes now an empty string, when you have now a string and a boolean here, it's going to prefer now a numeric coercion here. It's going to prefer now a numeric coercion. So since the numeric coercion of empty string is 0 and false is 0, then this becomes true. Holy fuck, bro. Holy. So be able to describe this is huge, is crucial here. So that'll be all for this video. Take care. Bye bye.